Hello, discrete math fans. Let's say you had a problem like this. You want to compute 36 raised to the 53rd power mod 11. Wow, that's a big number. Now, let's say you didn't have a calculator. This is still easy. It's easy. It's an easy problem. But it's tedious. Remember, big difference between easy and hard and tedious and versus not tedious. This is easy, but it's tedious. Performing an operation like 36 to the 53rd power, it's very straightforward to do by hand. That's a super easy problem. But it's a long process and it would take you a lot of time. Now our modular arithmetic theorem is going to help us a bit. Now 36 mod 11 is 3, so we can at least compute 3 to the 53 mod 11. You see, we have replaced 36 with 3 because 36 is the same thing as 3 mod 11. That helps us a little bit, but it's still very tedious to compute 3 to the 53. Now, all of these calculations are actually still very difficult even with a calculator. We're going to describe a very easy way to do these calculations, so we don't have to break a sweat at all. Now there's a couple of properties of exponents that we want to use. So if we have a real number x and positive real numbers a and b, then x to the 2a is equal to x to the a quantity squared, which is an offshoot of the fact that x to the a plus b is equal to x to the a times x to the b. Okay, nothing earth-shattering here. You've been using these properties for a long time. So anytime we have an expression of the form a to the 53 mod n, we can simplify it using the fact that the exponent, 53, we could rewrite that as 32 plus 16 plus 4 plus 1. Why is that useful? Well, a to the 53 mod n can be broken down by computing the modulus of various powers of a that are where the powers themselves are powers of 2. And it's not immediately obvious how we're going to make use of this. Let's carry on here. So let's go back to thinking about 36 to the 53 mod 11. Now we reduced it to 3 to the 53 mod 11. Now let's compute 3 to some powers mod 11 for a few values of p. Let's use 32, 16, and 4. That's going back to the fact that 53 could be written as 32 plus 16 plus 4 plus 1. All right, 3 squared mod 11 is equal to 9 mod 11, so that's just 9. Now let's keep going. We're going to build up higher powers of 3. So 3 to the 4th mod 11 is the same thing as 3 squared times 3 squared mod 11, so that's 9 times 9 mod 11. 81 mod 11, that's pretty easy to do. That's going to come out to be 4. Now we'll build this up to 3 to the 8th mod 11. 3 to the 8th is 3 to the 4 times 3 to the 4. And now we've already computed that when we reduce 3 to the 4, we get 4. So now 4 times 4 mod 11, that's 5. We keep building these up using successive powers of 2. So once we're all done, we end up knowing all the various powers of 3 where the exponents themselves are powers of 2. And we're going to use these results in our final calculation. Let's put it all together now. Now just to simplify our notation, because we're playing a little fast and loose, we'll use our congruence symbol to mean equal modulo 11. So remember our first step, 36 to the 53 can be rewritten as 3 to the 53. Now here's the key step. Because 53 can be written as 32 plus 16 plus 4 plus 1, we break up that exponent and then turn it into a product. And now remember that we previously computed what each one of these is equivalent to modulo 11, so 9 times 3 times 4 times 3. Here's the best trick. We're not even going to compute this whole product. We're going to break it down bit by bit. So notice that we're taking 9 times 3 and turning that into 27. And now 27 turns into 5. How does that happen? Reduction modulo 11. And we're going to keep doing this bit by bit. 5 times 4 turns into 20, and now we'll reduce 20 mod 11. 20 mod 11 is 9, and now we're finally reduced to 9 times 3. That's 27, and then we reduce that mod 11, and that gives us our final answer of 5. So without any very difficult computations, we're managed to compute 36 raised to the 53 mod 11. And remember what that means. It means that if we have the number 36 to the 53 power and we divide it by 11, we'll get a remainder of 5. Okay, that's all for now.